Okay, hello world. I think we are live on my side as well. Mike, Philip, could one of you say something so I can test the input audio here?
Yeah, I'm here.
Amazing. Sorry, I'm just muting. Okay, great. Thank you very much. Hello world. Hello Martians. Um, Welcome to the latest installment of the Urbit Developer Call series. I am Lane Rettig, otherwise known as Naplet Hildek on Urbit, and various Martian planets and Martian locales. Um, and before we kick off, just a very brief rundown kind of reminder about how this call will work and a little bit about the Urbit Developer Call initiative and series. So this is, I've lost count. I should know by now. This is like our fifth or sixth call, I think. And the Urbit Developer Call series is a grassroots community run initiative that is supported by a grant from urbit.org. So a big thank you to Josh and the urbit.org team for supporting this initiative. Urbit grants are awesome. And so if you are interested in doing a thing in the Urbit ecosystem, then you should check out grants.urbit.org. And because this is a grassroots and community-led initiative, we are always not just welcome to new faces and folks helping out, but indeed we definitely need help with running this event series. And Mike, our wonderful host of today's call, is great proof of the fact that anyone in the community is welcome to dive in and start helping out. Um, as a reminder, at the end of approximately an hour, so roughly the top of the hour, we will transition into a happy hour format. We will end the stream. Mike, we have to remember to end the stream. And we will drop a link in the usual channels, both on Urbit as well as the YouTube comment box. And you are welcome to join us in the Google Meet event that we're using to host this event to hang out and yeah, join the happy hour. Please feel free to drop questions at any point in either the YouTube comment box or in Urbit community. We have a channel, I believe it's called Event Series Discussion. So look for us there. And Josh will help us relay questions into this meeting for Philip and myself. So without further ado, I would love to kick off today's call. I do not have a prepared blurb to introduce Philip, but he is Wikdev Wizret. Did I get that right, Philip? Boy,
Dev
yeah,
Wisrite is how I say it.
Wikdev
But yeah,
Wizret. Okay, yeah. So Philip is a core developer, has worked on a lot of the architecture in the Urbit stack, and I think this is like maybe the third call we've done with Philip, so he has a lot of wisdom to bestow upon us. Um, but today we are talking about a topic that is especially timely, given the state of sort of gas prices in Ethereum and congestion in Ethereum, namely the Azimuth um, system, which is used to run Urbit ID on Ethereum. And of course, Philip was one of the key players involved in designing and deploying this originally last year, if I remember correctly. Maybe it was 2 years ago. Was it 2 years ago?
I think it's 2 years ago now. Yeah,
Yeah. And so, yeah, so the
so
topic is scaling Azimuth, and we're going to talk about various initiatives that are underway, or I guess the initiative, the various aspects of the initiative underway to address, the reality that it's now costs often, usually more than 100 US dollars in Ethereum gas just to do things like deploy a planet on Ethereum. So yeah, so format wise, I'll just hand everything over to Philip, and he will present on kind of past, present, and future, and then I guess I'll come back on and we'll do a conversation and relay some questions. So Philip, take it away.
awesome. Thank you. Yeah, so I've been running point on this issue, and I think most people listening here are familiar with it, either through Urbit or through other things, which is basically that to start using Urbit, um, if you want to have a permanent identity on Urbit, then you need to get a planet, usually, and you get that by, either purchasing it or someone transferring it to you on Ethereum. And Ethereum gas prices are very expensive, so the transaction fees for those are very expensive, which means that to start using Urbit with a real identity, the way that the way that you should be able to, it costs at least tens of dollars, and depending on gas prices, it could be higher. And of course, where uh, you know, there's no guarantee the gas prices will stay where they are. They could easily go significantly higher than they are right now. Um, and so the basic issue there is that when people show up, the first thing they have to do is spend a bunch of money. Um, and that's, not a great experience. It's also, uh, I mean, I think many people, certainly I would be happy to, spend $100 on a planet after I've used it for a few months, and proven that it's worth it to me. But um, it's not great for that to be the very first thing that happens. Um, right. So we should back up just a little bit and explain why, uh, what we use Ethereum for. This is covered largely um, in a blog post that I posted last year, called something permanent identity, um, like designing a personal permanent identity, I think. And that is, um, it goes through basically the idea maze of decentralized identity. And um, the like the the basic flow of the argument is that if you want an identity that's actually yours and that's actually permanent, then it needs to be not under the control of any centralized party, of any central party, and also it needs to be something that where you can update the keys over time. Because if you can't update the keys, then um, you're only going to last as long as you keep that key secure. If your identity becomes more valuable over time, you need to change keys. If your keys are compromised for whatever reason, you need to change keys. If the crypto system that you were using is compromised, you need to change keys. And so something like that is just impermanent. Um, and so there's a few different solutions to this general problem. We sort of implement all of them. One of them is comets, which are self-attesting keys, but they're not permanent because they can't be changed. Their address is literally just a hash of their key. Um, Another is moons, which are basically centralized or centralized around their own planet, where you ask the planet for the key of the moon. So the moon is not something that exists independently because the planet could always just change what it reports as its keys. And then the last solution is what we use for planets, stars, and galaxies is to store them on Ethereum. Um, and that needs to be a blockchain basically because that's the only way that we know how to agree on who owns what, without there being a central party. Otherwise, you basically run into a double spend problem of if the old keys are compromised and they send, a message saying, "Here's my new keys." n- Um, if you have two of those messages, how do you know which one's real? And so a blockchain gives you a canonical ordering on those, and then you just define that whichever one happens first from the perspective of the blockchain is the real one. So that's the background that gets us to where we're at now. And let me present some notes. Um, I am going to assume everyone can see that. Interrupt me if you can't. Um, and yes, I'm a simple engineer, and so I present from Vim. Um, yeah, so the problem is what I just said, which is we need to be able to get planets, we need to be able to get them cheaply. Um, we also have various properties of our current system, um, which for those who are familiar, our current system is Just regular Ethereum smart contracts, ERC-721 tokens, um, very standard. Um, and this is, um, mm, I'll go into criteria first, and then I'll say what I was about to say. Right. So the criteria that we need and that we get right now is that your ship needs to be permanently yours. It needs to be yours for at least as long as you want it to be. Obviously, if you throw away your keys, then it's gone. Just like when you're running Urbit, if if you're running it on a Raspberry Pi and you throw away the Raspberry Pi, then yeah, your data is gone. But it is what we sometimes call subjectively permanent, which means basically it's there for as long as you want it to be, as long as you take reasonable precautions. Um, so that's an important criteria of both, your data on your ship and also your identity, because your identity is an important part of your online existence. Um, and if in order to be a true exit from the world of mega corporations, um, you have to be able to, you need to be able to have a way, an identity that you own that doesn't depend on logging with Facebook or logging with Google or whatever. Um, Second property we need is that we need Urbit ID to be censorship resistant. This doesn't mean this doesn't have to do with landscape or Urbit OS. This doesn't mean you can say whatever you want in any chat channel. Um, I'm talking specifically about the transactions that have to do with your Urbit ID, which are basically, running personal breaches, rotating your keys, changing your sponsor, transferring your ship to someone else, and if you're a star or a galaxy, spawning stars or planets. Um, and so in order for something to be yours, you have to be able to do those things with it. Um, and so we want whatever solution we have to be reasonably censorship resistant, which means that there's no small group, or ideally not even like a percentage uh, of some group that can block you uh, from running those transactions. Um, there are, of course, limits to what we can provide. Like I said before, with the data on your ship, if someone shows up, takes your Raspberry Pi, it's you don't have your data anymore. The nature of ownership, of course, is that it is fundamentally consensus based. Like everyone has to agree. Um, Not that everyone has to agree, but it has to be generally agreed upon. And if the whole world decides that you don't own your house, then there's no practical sense in which you do. And same for your Urbit ID. So we don't need to provide against, like we don't need to protect you against the whole world not believing you because we can't. Um, but outside of that kind of sort of global threat, we should be basically as permanent as possible. Um, yeah, Urbit as a project basically takes the let's try and be as permanent as possible as far as we possibly can. Um, and to some extent, the only reason that anyone has any faith in us as a project, to the extent that they do, is that we're stubborn enough that we might actually build something like that. Um, to the point where I think for most of us working on the project, if it came down to a choice between trying to do something that's actually decentralized and owned by you and failing versus compromising on that and making it something that is no longer properly owned by you, we would prefer the former. Um, yeah, so that means basically that whatever solution we choose needs to be actually decentralized. If it's not actually decentralized, um, then it's just theater, and we should just store it in a Postgres database maintained by Tlon. Don't have to depend on other third parties. It's more efficient, more honest. And so I yeah, I have ultimately little patience for any choice that says, well, we'll just make it a bit more centralized because it's like, well, then what are we doing here? Um, so 4 classes of solutions. Although I should talk briefly about uh, why gas prices are so high, which is basically that on Ethereum and blockchains like it, everything that gets run on Ethereum has to be run. So every app that's running on it, all the transactions associated with it, have to be run on every Ethereum node throughout the world. And each of those Ethereum nodes, has a certain amount of power, and they need to be relatively small, because you need to be able to have a lot of people running Ethereum nodes. I Ideally, they need to be able to run on, reasonably just like commodity hardware. You shouldn't have to have, racks of servers to run an Ethereum node, because then only a few people would, and then you're basically centralized. Um, and so that means that there's only a certain, number of transactions effectively, or that can be sent in any given time, and we are competing for those with every other um, application on Ethereum. And so that's done by an auction, and for what they call gas, and the gas prices are high for that reason. And so there's a variety of different attempts at solving what they call the blockchain scalability problem, and I'll go through some of the ones that are relevant to us. Um, so the first class is what they call the Ethereum killers. These are blockchains which have smart contract capability, but have much lower fees. Um, and the way they do that is they accomplish, or is they is okay. So it's basically 2 ways they do this. One is fewer people use them, and so when there's less congestion, that means lower fees, especially once you get below that threshold where not every block is used to its maximum degree. Then um, fees are no longer have, what can be called a monopoly price. They have their price is set purely by the supply side. How expensive is it to run the transactions, um, compared to just, on Ethereum, you have a sort of demand side pricing, where it's how much are people willing to pay. Um, right. So that's one of the most common ways that fees can be lower. This is the way Ethereum used to be, years ago. Um, the other way that they can do it is by becoming less decentralized. They can use fewer nodes, or the causation often goes the other way around. They can require the nodes to be more powerful. They have more bandwidth, um, more CPU, more memory, um, and by doing this, you can just process more transactions. Um, the issue, of course, is that you end up having fewer people willing to run those nodes, and it becomes impractical for you to just run a node like that in your house, unless you're willing to put a lot of work and money into that, which makes it obviously less decentralized. And so, as I said before, need to be decentralized. Otherwise, well, number one, there's no point. Also, if there's only a small number of miner validator nodes, or just full nodes in general, then that makes them vulnerable to censorship concerns, definitely, or collapse, if a few entities have issues, or regulatory issues, or financial issues, or whatever. Um, and so that's a real problem. Um, the the ones that are less used also have basically very little security, against various attacks, especially 51% attacks if it's proof of work. But most attacks depend on basically a large, healthy community of miners or validators. Examples of this recently include Ethereum Classic, which has been 51% attacked many times in the last months, and Verge, which was recently um, 51% attacked all the way back to July. So they rewrote every transaction since July. Um, and that kind of thing is is simply not acceptable for us because it's not yours if some attacker can come along and censor all your transactions later on, for example. Um, or if it got sold to you and someone comes along and then takes it back by rewriting the blockchain. So those are not real options. Um, Obviously, ones that are not used, not only do they have little security, but they're going to become expensive later when they are used. Um, this tension, by the way, um, is known as the like blockchain scaling trilemma, I think, which is that basically you can choose any two of three of security, decentralization, and scalability. Um, and Ethereum killers are basically ones that chose are usually ones that chose scalability and one of the other two, and just completely didn't, they gave up on security or gave up on decentralization. So those are not reasonable options for us. Second class of solutions is blockchain in a box, which is basically where you download a package and scribble your name in a few places, and now you have your very own blockchain. Um, Cosmos and Polkadot are the big players here, at least the ones that I've looked into the most. They both are doing very interesting things. Um, they generally so the issue with a with your own chain, of course, is that you need to secure it yourself. Um, and so they generally operate as proof of stake because that's easier to sort of get going than a proof of work chain. And with proof of work, you're sort of competing against the other proof of work chains, and you're not likely to do well against that. So proof of stake is a common way to do it, which people are concerned about for various reasons, but they might be able to get working in a safe way. Um, but you also then for proof of stake, you need to have some kind of token that you can stake and that you can burn. And so our options, if we wanted to do that, would be create our own token explicitly for this purpose, which, aside from any regulatory issues, it doesn't feel great to just make a token that we hope has value just because, like, where its only use is as transaction fees for this. Um, it's sort of not well thought through. And then secondly, of course, that token needs to have immediately a lot of value to be able to secure the assets that we already have on chain. Because if your stakeable token is not worth, at least roughly as much as the the galaxies and stars and stuff that are out there, then you can make a lot of profit by just buying a bunch of the stakeable token and using that to manipulate the blockchain. Um, so there's a problem there. Um, you could try and get around this by using galaxies as validators and saying basically either we're just not going to burn stakes, which means that you end up starting to trust the galaxies. Basically, it becomes more of a proof of authority than a proof of stake system. Um, and then you'd be trusting that at least two-thirds of the galaxies are willing to service you, um, which, or for many attacks, you're trusting that at least one third are willing to service you, um, which is not ideal, but maybe not the end of the world. It's still like from a censorship resistance perspective, I'm not super satisfied with that. Or you say that we will burn galaxies or burn stars or burn planets or something, which also doesn't feel right and feels like getting the game theory and economics of that correct um, is going to be quite a challenge. Um, uh, Polkadot does have or will have something called a relay chain, which lets you ideally use their own like this one main relay chain that stakes their own dot token as your shared security. But it is First of all, as far as I'm aware, not available yet. Second of all, um, it requires your chain to purchase space on the relay chain in general, and it's not clear how to do that as a decentralized network. Although I don't know, maybe there's some kind of solution to that. I mean, Klon could pay for it, but then what if Klon stopped paying for it? Also, it's not cheap, um, and it's also complicated as far as data availability goes, because that data still needs to go somewhere. If it's on our own chain, great, but for Polkadot to be able to ensure security, it needs to have some of that data as well. And it's not clear that that can be done in a scalable way. That's not going to have a bunch of fees. Like it's not going to have high fees, anyways. But still, I think that there's possibly a future for a Cosmos or Polkadot. Um, Certainly for other people and possibly for us in the future as well. Um, One more issue related to using galaxies as validators is that um, for censorship resistance, something that Ethereum and Bitcoin depend on is that since miners are anonymous, their only incentives are the ones that are sort of built into the protocol. Their incentives are the transaction fees in general, and in particular, they're not incentivized to censor any individual people unless they decide that they want to do that on their own. There's no way that there can be social pressure to censor individual people because you can't pressure someone who is anonymous. Um, and so for censorship resistance, it's actually really nice to have your miners be anonymous. If we use galaxies as validators or even stars, um, or even planets, anywhere that you have some kind of valuable identity associated with it, human identity or machine identity, like a planet or something, then it becomes a much more complicated game because now you have a bunch of social concerns to think about, and while those social pressures are often healthy, um, for the specific goal of providing decentralized ownership, like ownership separate from social concerns, um, that gets seriously compromised um, by having your miners or validators be known people. Um, so you usually want those to be anonymous. Another way you could resolve this would be if your transactions go dark, the way that like Zcash ones are, where when you look at a transaction, you can't see who it affects, who sent it. Then galaxies wouldn't be able to discriminate uh, based on what's there. It's like using a VPN to access stuff. Your ISP just has to decide, are we going to allow VPNs at all or not? They can't choose then, uh, to censor individual sites or anything like that. Unfortunately, the ZK proofs are not really there yet. I mean, the math is there, but the implementations are not. Um, at least it would take us a while to build, essentially. Um, there wouldn't be that much new stuff we'd be building, but it would take a while. Um, Next option then is Bitcoin. Um, in my opinion, basically nothing on Bitcoin is ready for general use. Nothing of general smart contracts is ready for general use. Um, Even though there's been many, many years of people saying, "Well, why don't you just do smart contracts on Bitcoin?" And the only thing that looks like it's maybe usable right now is Rootstock, which basically has similar problems to Ethereum killers. Their scaling proposal is literally, as far as I can tell, wait for Ethereum to find out how to scale and then copy that because Rootstock is a EVM compatible sidechain. Um, and so that's not like, that doesn't actually solve the problem. The only reason fees are cheap on rootstock right now are that, um, nobody uses it, and so that doesn't really solve the problem. Um, Bitcoin SV, the problem is basically the blocks are too big, or at least they can be too big, and so the number of validators, or even of full nodes, much less miners, is always gonna be small, um, and so it's not just sufficiently decentralized. Um, Even if the number of validators is relatively large now, I actually don't know how many there are right now. That's because BSV blocks are not actually that big right now. But if they become, if BSV becomes more used, the blocks will become too large, and you're just right there on the security and scalability. Sorry, yeah, security and scalability side while sacrificing decentralization. And at that point, just use Postgres. Um, That leaves our fourth class of solutions, which is Ethereum layer 2 options, um, which there's been a lot of discussion about for a long time. Some of the older options are still around and still have some merit. State channels, like I think Raiden does state channels, but this is similar to like Bitcoin's Lightning Network. Have some nice features, but it requires all parties to remain online until it's resolved to layer 1, which is not a great property because it means you kinda have to, stand watch over your identity for a while, and that's not something you should have to do. It makes it more of like you're renting your identity rather than owning it. Another option is Plasma and related stuff. Um, this is where you keep the data off chain, for each individual application and just commit state hashes, um, and then you have a series of challenge games to be able to prove various sorts of uh, either fraud or just unavailability in the side chain and exit to layer 1. This is what everyone was excited about in 2017, and it turned out to be basically complicated, not suitable for general computation, um, and have various sort of implicit scaling limits, um, surrounding how to get everyone off of the side chain that are not straightforward to solve. And so most people have moved away from Plasma as an option, and many of them have gone to rollups, which are the state of the art in Ethereum layer 2 scaling, um, and seem like the most promising option in the short term, at least for us. So the basic idea of a rollup is, instead of running your transactions on chain, meaning on everyone's nodes, and also storing the data on chain, you send the transactions in batches, um, sort of through the chain, but they don't get run on chain, and they don't need to be stored on chain afterward. They'll usually be stored at least for a while uh, on everyone's nodes, but they're not required to be stored to be able to continue going forward with the blockchain. And they don't ever get referred to. They can't be read from within the chain, and so they can be stored. My understanding is that Ethereum nodes right now, at least Geth ones, are able to split their storage between SSDs and hard drives. Like they have this stuff that's accessed often, this stuff that's not. And so transactions like this would be stored in the one that's not accessed often, because the only time it's ever used afterwards is if someone queries for it specifically, or if you're sending these transactions to someone else who's syncing from scratch. All that to say, basically, you're not running the transactions on chain, you're not storing them on chain per se, and so this is much cheaper. Um, it ends up being roughly 100 times cheaper, um, which is good. It's not, it'd be nice if it was even more, but it takes, if spawning a planet costs $20 today, then it would turn into cost 20 cents, which is, yeah, better, definitely. But hopefully we can do better someday. We'll see. Um, with a so with a roll up, there's this idea that you basically deposit assets to that roll up usually. And if the thing that you're usually sacrificing with that is the ability to interact with other stuff on the chain. So those tokens can't interact with smart contracts or decentralized exchanges or anything else on chain, unless you can somehow commit a state hash to chain that people can trust. Um, and so there's a few ways that people do that. One is something called optimistic rollups, which is you anytime you submit a batch, you also submit the state hash after running that batch, and then you basically the aggregator just asserts that. Aggregator is just the person who submitted the batch. Um, and then if anyone wants to challenge it, they can supply a fraud proof, which is relatively compact and is non-interactive, that proves that uh, the state hash is incorrect, that the aggregator lied about that. Um, and usually the aggregator will have put up a stake and their stake will get slashed. And in particular, those transactions will be reverted. Um, this has some disadvantages, like obviously there needs to be a challenge period before you can actually trust the state hashes that are on chain because someone needs to be able to challenge it. Um, the biggest disadvantage is basically the complexity of the game theory involved and the fact that it relies on a property of blockchains that blockchains don't actually have. Specifically, the ability to get transactions through on the main chain in a specific time window, um, which is not a guarantee that Ethereum or any regular blockchain can provide. Um, it Blockchains say that transactions will generally not get censored over sort of an indefinite time horizon because eventually the attack will become too expensive. But with something like optimistic rollups, there's a definite time period where you don't have to censor them forever. You just have to censor them for 1 week, and then you can take all the money that's in the rollup. Um, and you could even potentially do this in a decentralized way, um, where the miners, if they're acting rationally, should censor those transactions because they're going to get a payout um, after after that 1 week challenge period. And the responses to this that I've seen are primarily basically say, well, it's hard to coordinate miners, and so it's that attack's probably not actually going to happen. But I'm wary of any system that assumes that miners are going to act irrationally because it's hard to coordinate. Um, and so I think that there's sort of serious problems with this, and ultimately, I'm not comfortable with the game theory involved. Um, and so I think optimistic rollups will be useful for some people in the short term, but are not a long term solution. And so we should probably skip those basically. Um, Next option for providing that state hash with each batch is to include a zero knowledge proof with that. So this is a reasonably cheaply verifiable cryptographic proof that says that this batch of transactions was run um, correctly and produced this hash. And so specifically, it can be verified cheaply enough that it can be verified on chain. So whenever you see a state hash on chain, you can know that it's already been checked. It's already accurate. Um, this has some nice features. Um, Obviously, you don't have this challenge period. You get to use cryptography instead of game theory to guarantee that. Um, it is not ready for general smart contracts on mainnet, but it looks like probably within the next several months, we will see one or two implementations of that, which is exciting to see. but you never um, with Ethereum scaling stuff, anyone who's been around for any period of time at all knows that you shouldn't depend if you can avoid it, you shouldn't depend on other people to write code because it always takes them longer than they expect. And with scaling proposals, a disconcertingly large number of large amount of like disconcertingly often you like it turns out that that proposal just doesn't really work for some reason or another. Everyone was super excited about plasma for everything, and it turns out it's very limited use actually. Um, Another thing with zero knowledge rollups is that when you're sending these batches, and these batches come with this proof, you generally have a whitelist of aggregators. So the only specific set of people that can that can send these batches, which is a central point of failure. Um, and so for censorship resistance, if for some reason they stop servicing, so either if they disappear altogether, and so there's no aggregators for anyone, or if they stop servicing you for some reason, for example, due to, I don't know, sanctions or whatever, then you can always go to uh, the layer one and use expensive transactions the way that you do now. So you can withdraw purely from layer one without any permission from the aggregators. And the aggregators, of course, have no with all the rollups. The aggregators have no ability to take your stuff. At least not without like an attack on optimistic rollups. But like the only power that they have is censorship, and so you can get around that by just withdrawing directly to layer one. Um, it's debatable, of course, whether this is true censorship resistance to say, well, you can just use layer one where it's 100 times more expensive. Because, when stuff gets too expensive, it's not free, right? When, like, making something 100 times more expensive in some cases is just as good as disabling it altogether. For example, if you own a star and someone stops servicing your spawn transactions, and planets cost say $20 and it costs you $100 to spawn a planet, then essentially your spawn transactions are censored, at least for any economic purpose, because now it's going to cost you $100 instead of $1 to spawn, and there's no way you can make money on that. So I like ZK rollups as an option. Um, there's really a lot to like about it. The aggregator whitelist thing is not great, um, but it's not that bad, and I think it might be a reasonable trade-off. There are plans that some people have for decentralizing the aggregators, making it so you have to maybe have a stake, and so then anyone could just accumulate enough of the right coin and stake on it. I'm optimistic about that in the future as well. Let's see. Um, all right, last type of solution we'll go through is naive rollups, which is where this is something like I call them naive rollups. I haven't seen that term in anywhere else, but it's basically where you don't include a state hash on chain at all. You just include the batches. Um, the biggest disadvantage, of course, is because you don't have a state hash on chain. There's no way to withdraw back to layer one. You can't interact with smart contracts on layer one. You're really in a whole other world. Um, Hopefully, at some point, we later transition to ZK rollups, or we become comfortable with optimistic rollups or something like that, and then you can withdraw back to layer one or to another layer two or something trustlessly. But for the moment, the answer will be once you're on naive rollups, no way to go back to layer one. Their biggest advantage is that we can do it all ourselves without relying on anyone else to write or run any code. The code would just be run on everyone's ships, and it's just code that we can write that's not even particularly, there's nothing groundbreaking about it. Um, and so from a security perspective, it checks all our boxes. It uses exactly the same security assumptions, like it's based on the same security as layer one. Um, the only additional, threat basically would be the state transition function for the roll up. It's just more code. It's because you have you just have basically a longer specification because you have to specify, okay, here's the smart contracts on layer one, here's the smart contracts on layer two, and here's how they interact. Which is just a bit of a longer spec, but it's nothing. It's not that it's not that big a deal. Um, Certainly, much like it doesn't rely on like everything else introduces a lot more security assumptions than naive rollups do. Aggregator wise, anyone can be an aggregator by just submitting a batch, which is sort of perfect from a censorship resistance perspective. If you're being censored, you can submit your own batch, which is going to be relatively cheap. If you want to do a lot of transactions at once, it's going to be even cheaper. If you and your other buddies want to all put it all in one batch, it's going to be quite cheap. So, that option. So, in the time we have left, I'll try and talk about basically how we think about these, um, like where we're at in the decision process, basically. Um, Naive rollups are nice. Like I say, they don't violate any of our security or permanence requirements, which is almost unique. ZK rollups also don't properly violate any of them, except that they get maybe a 4 out of 5 in censorship resistance. You can't be truly censored, but you can make the transactions more expensive. Um, Everything else violates one or more of these base requirements. And so that's why, well, that or they're not ready, which is also, I don't know, permanence to me is not just it will exist forever, but it also already exists, um, or at least will within the next few weeks or something. Um, right. So if zero knowledge rollups were ready as a generic solution right now, I would think that would be the right answer. Um, I think that basically we're within a few months, several months, it's hard to say, um, of this happening, but it's not there yet. Um, and so Immutable X is an interesting option for this. There are an application built on Starkware's technology that supports minting, transfers, and trading. Um, and so if like they've built a fairly basically generic NFT platform, um, and if we can get our like spawning logic to work with them, then it might be a good place to uh it might be a good option that require relatively little of our reliance on them, would require relatively little work to implement, and would make things quite cheap. Um, in terms of we would be depending on them to some extent, but if they disappeared, obviously you could always escape to the main chain. Um, yeah, so they're an interesting option. We're talking with them. Um, we'll see what happens. If that does not work, then I think naive rollup's the best solution. We can build these ourselves. They have everything we need. Um, I estimate about a 70% chance that we end up doing these. Um, and so I've started building these. Lane has been while talking through all this stuff with me as well. I've checked with some other people. And we're working on seeing if we can build these. Um, I'm gonna skip the mechanical explanation of how these work, just because it's not that interesting or that important. Um, the short version is basically instead of something like Bridge talking to an Ethereum node, sending transactions to an Ethereum node, listening back from that Ethereum node to find out who owns what, you'd put a layer in between where instead of sending a transaction to an Ethereum node, you'd send it to an aggregator, which would then periodically dump it on chain. And instead of reading from an Ethereum node, you'd read from an Urbit ship that has been watching these batches and running the state transaction function itself. Um, And so one way to think about this is that it's instead of using Ethereum as a computer, you use it as just an event log, and then you use Urbit as your own ship to run that event log. Obviously, the event logs fully specifies the the state, um, but you use your ship to to actually make that into something that's conveniently queryable. Um, and of course, well, there's a few ways that you could specify that state transition function, specify basically how to process those batches. I think that the best option is probably to specify that in Hoon, as just a blob of compiled knock that we, similar to how we have our blob of solidity that specifies it on layer one, you'd have sort of a Hoon smart contract that would specify it in the naive rollup. They would say, okay, this is how you verify transaction signatures. This is how you decide who can transfer what. And that should, uh, yeah, like that's uh, like knock is a pretty good specification language. So I think that'll work out all right. All right. Um, Last point I want to make is with migration. Um, if it was something like ZK rollups, I'd be tempted to migrate everyone automatically because and then you go back to L1 if you really want to. But with naive rollups, I think that we should do it 100% opt-in because going to naive rollups is, you give up something. You give up the ability to go back to layer one, interact with smart contracts on chain. And so the way that I would see this happening is you would deposit a ship. Um, so if you want to go to an A rollup, you would send your ship to a designated address, and that address would have no private key, and so there'd be no way to transfer it back on layer one. And then on layer two, we interpret that transfer as transferring it to layer two, and then you can control it afterwards with layer two transactions. And then hopefully at some point we can slap a zero knowledge proof or something on it, and you be able to transfer back. Um, but nothing that exists. So sorry, nothing that does not exist yet exists, and so uh, no guarantees. Yeah. Okay. So that covers sort of the state of the race as far as scaling solutions go. And I'm yeah, I don't know if Lane has questions, and then after at some point we'll get also to questions from the audience.
Hey, Philip, can you hear and see me okay?
Yeah.
Awesome. Um, yeah, thank you. That was really fantastic and really educational. We've had a lot of really exciting conversation happening, especially on the YouTube channel. So a few folks have said this same thing. This has been a very exciting talk. This is obviously an extraordinarily complicated ecosystem, and I can tell how much work and thought and research you've put into this. So yeah, on behalf of the entire sort of project and ecosystem, thank you for this work. I know that this stuff is not the simplest stuff. It's taken me years to get up to speed, and I'm still learning every day as well. Um, yeah, we are nearly at an hour already, and I thought I might actually just transition directly into community questions, if that's okay with you, Philip. I'll convey the ones I've seen, but Josh or Mike, if you folks are listening and want to jump on with other questions, please feel free to do that as well. Um, the first question I wanted to convey is talking about the zero knowledge proof based rollups. You talked about how the aggregators or sequencers are whitelisted. A couple of folks have asked why there's a need for whitelisting.
Right. So there's a lot of different techniques here. And I don't think we'll always need whitelists. Um, but so there okay. One of the issues there is that um these batches are like the proofs, while they're cheap to verify, are actually quite expensive to generate. Um, it's on the order of thousands of times more expensive to generate the proof than it is to just run the transaction itself. And so if you have a batch of hundreds or thousands of transactions and you spent all this time proving it, then if someone else submits a batch, then you've lost all that time that you spent proving it, which might be worth as much or more than the actual gas cost. In particular, if it is more than the gas cost, then there's a straightforward sort of griefing technique, which is that anytime that you see in the mempool someone bidding for one of these batches, someone submits one of these batches before it's been confirmed, you send a transaction with higher gas price that that has just like one, it's a batch with like one transaction and a little proof with it, which was really cheap for you to generate, but it invalidates the really expensive one that other person sent, and so they lost all their time of proving it, and also their batch transaction and all the gas associated with that also gets burned because their proof fails. um, Although if you can do that, if you do that carefully, you won't burn too much gas. um, and so you want to have some sense of whose job it is to do the next one. And you can imagine various schemes that have like probably a good option would be a scheme that works well in the normal case where everyone's kind of cooperating, just some kind of round robin, everyone gets a chance. And then you just need to make sure that if someone starts behaving poorly, maybe it takes a little longer for a batch to get through, but eventually it can get through somehow. Um, and I mean, one of the techniques you can do for that is separating the batches from the proofs, so that you know what the batches are, and then someone just submits a proof later on. Um, I think that like there's a lot of hope for that, but everyone who's doing this right now, that I've seen at least, uses a whitelist, and so at least for the short term, this is the issue.
Thank you. Yeah, that makes sense. This problem, which we tend to refer to as leader election in sort of blockchain and distributed systems, is in and of itself a difficult problem, as you're alluding to. How do you keep a network live if one or more of the validators or sequencers or whatever you want to call them, verifiers, disappears or acts Byzantine or something? And so what are your thoughts for naive rollups? I have to slide in here. I like the name naive rollups. I like to call them black hole rollups. You probably heard me say this before because you can roll in, but you can't
Yep,
roll out at least until, so it's like a one-way rollup. But how do you think we would
roll
do,
in.
what's that?
Yeah, I like that, roll ins.
Roll-ins. That's actually not bad either. It's simple. Do you think we would
Yeah.
use a whitelist, for kind of V1 of this? Do you think, how do you think we would do this leader election? Is it a free for all? Would there be multiple sequencers or just a single one?
I think you're probably fine just making it a free for all. The uh the only way to because there isn't the cost of generating the proof, and any batch that's submitted um will be valid. The only the only way you could sort of waste gas from some perspective is if you send a transaction that made one of the transactions in the batch. If the attacker sends a transaction that makes one of the attack transactions in the batch invalid. But the only way they can really do that is if it has to do with one of their own ships, because everyone controls their own ship, and so if they send a transaction that makes their own transaction invalid, I mean, that doesn't they wasted their own money basically, unless they were getting a free transaction from them somehow. But even then, they had to spend as much as they cost the other person. Um, and so, yeah, I think we could just say anyone can submit a batch.
Cool. That makes sense. Yeah. Keep it simple. Uh, yeah. Sorry. This is such a deep, fascinating topic, and there's like so many nooks and crannies to explore here. But again, I'm trying to be mindful of time. One last community question. I'm going to paraphrase here slightly. Um, if if the sequencer I'm using the term sequencer again. I know the terminology is a little up in the air here. I think you use the term validator or verifier, which is perfectly okay too. But if the sequencer kind of acts Byzantine, acts malicious, disappears, something like that, um, then what do you, as the owner of Urbit address space of a star or a planet or whatever, like what is your recourse? And the way this question was phrased originally is something like, what does ownership mean if you were to hypothetically like lose control and not be able to, let's say, change your host or transfer the ownership or something? Does that question make sense?
In the context of ZK rollups or naive rollups?
Naive rollups, right? So how do you meaningfully own your planet, let's say, if the sequencer is responsible for like updating that database and the sequencer decides to like lie or go offline or something? Like, do you still own it? And how is that
So by sequencer, do you mean the aggregator who's sending these transactions, or the person who's reading the batches from the train from the chain and saying and saying who owns what, the same way that like an Ethereum node, you can query an Ethereum node right now to
the
see who owns what.
the former? So I'm using the term
The
sequencer to
former.
mean the same thing as aggregator.
Okay, yeah. Right. So if they go offline, because anyone can be an aggregator, you can just submit your own batch. Um, if it's just one transaction, is going to be a bit more expensive. It'd be about 25,000 gas, which is actually still cheaper than what we're doing now. Um, but it's it's still going to be cheaper than, or like but in particular, if they go offline, you're going to have now a bunch of other people wanting to do the same things, and so they have to coordinate a little bit, find other people that are willing to just send them transactions, and maybe pay them or something. You end up with a little bit of chaos while people are uh finding out who's willing to batch these up and take payment to be able to send these, because the aggregator has to take payment because they're the one who's paying the cost of the batch. But even if you just do it with some of your friends, or if you're sending a lot of transactions, you can do it just with yourself, because once you get past 10, or especially if you get to like 50 transactions, you're pretty close to the cheapest that it's ever going to be, because it's a rational curve. It goes like, looks like a 1 over x curve. um and so your batches don't have to be that large before you're saving most of the money anyways.
Great, that makes sense. Yeah. So I guess the point to reiterate here is that all of the sort of essential data required to reconstruct the current state um, does exist on Ethereum, and we're using Ethereum for data availability. And so anyone, anywhere, there's sort of a couple scenarios, right? One is that they've been online the entire time and following, participating, following this sort of roll-up contract the whole time, which all ships should do and will have to do, right? And so they kind of know the
Mhm.
current state already. But even in the case where, let's say, you're just booting up a new ship, you could still kind of rewind and read all that data, reconstruct the current state, and then you can always create a transaction yourself and submit it to L1 yourself, with or without, as you were saying, like other transactions. Of course, if you were to submit without them, then it would be more expensive. But the point is, you you still have this guarantee at L1, right? That's why you still have meaningful ownership of your address space. Is that accurate?
Yes, exactly.
Cool. Okay, wow. Yeah, as I said, this is such a huge topic and there's so much more to discuss here. I already have a strong feeling that we're going to want to revisit this topic soon, here on a developer call or in another format, probably both. Um,
Yeah.
Mike, lovely to see your face again. Did you have any last comments or questions? Or I don't know if Josh had any he wanted to slide in as well. Otherwise, we can maybe transition to happy hour.
Yeah, just two real quick ones. When we end the stream, there'll be the link for the happy hour, so everyone's welcome to come join us in the room and talk over some of these issues in more detail if you'd like. And secondly, we're going to be running these developer calls every other week, and we really would appreciate any input. One, if you would like to present, that'd be fantastic. Or if you have any suggestions for topics or things you'd like to see, let us know. You can email me directly, mike@urbit.org, and we'll be happy to entertain that. And I think all of that did not go over the stream because I just turned the microphone back on. I know. Let me quickly announce that again. First off, uh, thanks to Phil, a fantastic presentation. We really appreciate it. We're going to be having a happy hour right after this. As soon as the stream is over, we'll be bringing up or as soon as this is over, we'll bring up a screen with the stream. Everyone's welcome to come join us and discuss this or any other topic with the rest of us. And secondly, if you are interested in doing a
Hey,
presentation,
Mike, I think
yes,
we can't hear you on the live.
He's already fixed it. It's just because there's a delay of a few
oh, there's
seconds.
a lag.
Yeah,
Yeah.
we're good.
Sorry. Yeah. You got a rookie engineer here. Anyway, if you would like to give a presentation or you have a suggestion for a topic, please let me know, mike@urbit.org, and we'd be happy to entertain it and get you scheduled. So that's all I had. Thanks. All right.
Yeah,
So
amazing. Thank you, Mike. Josh, anything from your side, or should we transition?
I think he's on the lag.
Yep, I was lagged. I think I should be back now.
Josh, anything final from your side, or should we transition over to happy
No, I think
hour?
we should head over to the
Okay,
happy hour.
let's do it.
We can.
Okay, I will
There's
put the
questions
link up.
there.
We'll leave it up on the stream for a few minutes, and please join us in the room. Thanks.
Thank you, everybody. See you at the next developer call.
Bye.
The screen share. Right, you can stop the recording. Perfect. No worries at all. No, it's totally fine. I mean, I've done this enough times already. You probably, yeah, it's fine. And you did a great job with the streaming. As I said, it's a lot juggling all this stuff, but it gets easier, I promise. Sure. Cool. It showed up, yeah, and then Josh dropped the link in YouTube, so I think we're fine. Yes. There we go. There's Mark. We know it worked. Good. Hey, Mark.